Hey everyone, it's Mr. Anderson. Today we're going to look at section 10.2.1 from our CPM Common Core Algebra book, and our goal today is to look at doing some rewriting for the purposes of making problem solving easier. You can see that I've got section 10.2.1 pulled up, and we've already talked about solving linear, quadratic, and exponential equations in this course. We've used several different methods for doing so. But when we've got a very complicated looking equation, it can often be rewritten in order to make that problem solving process easier. And today we're going to look at a couple strategies, have you do some practice to give you a little bit of experience with that in order to make you a more effective problem solver. I've got a couple problems pulled up in our modified notes here, and I'll do some writing, but as always you can find these things in our ebook with solutions, with some extra explanation if what I'm talking about does not always resonate with you. So if something doesn't make sense, pause, back up, rewatch. Otherwise, ask your teacher or search for meaning in that text. But let's check out problem 10-22 here in section 10.2.1. Cassie wants to use the zero product property to find the x-intercepts of the quadratic function, and she's specifically looking at this one right here. X squared plus 1.5x or 1.5x minus 2.5 equals y. So she started factoring. Suddenly, Claudia blurted out, "No, Cassie, I think there's another way. Can you first rewrite this equation so that it has no decimals? Then it will be faster and easier to factor, and we won't have to use the quadratic formula." So part A asks, hey, what is she talking about, and explain what she means. Then rewrite the equation so it has no decimals. Well, she's talking about the fact that 1.5 and 2.5 are decimals. They're rational numbers. They're not integer values, right? We factor with integers because the factoring process is less complicated. So, is there something we could do to eliminate those things and make this easier? And the answer is, of course. Because it's 1.5 and 2.5, we could go ahead and we could eliminate those 0.5s or those halves by doubling each thing. So first thing I'd probably go ahead and do here in part A is I'd set this whole thing equal to 0, because if we're doing some solving for the purpose of finding the x-intercepts, that's what I want to do. And then if I'm going to double it, I'm going to literally take the whole thing and do some doubling. So I can just treat this like a giant massive distributive property, and technically it's correct to double the 0, but we all know what 2 times 0 is. 2x squared plus 1.5 times 2 is 3x minus 5, and that's equal to 0. Now we can start this factoring process, and if you need to, go ahead and use those algebra tiles. Okay, but you probably recognize that the factors of 2x squared are 2x and 1x, or 2x and x. Now it's just a process of rearranging the 1 and the 5, because 5 is a prime number as well, so that we get 3 out. And the way that we do this is by not multiplying the 5 by 1. I'm sorry, the 5 by the 2, because that would give us 10, and that would be way too big. Now check this out. I'm going to just draw this in like an orange arrow here so you guys can see. I'm going to end up multiplying the 5 by the 1 and the 2 by the 1 here, and so I can have 5 minus 2, or 5x minus 2x, which gives me the 3x I want, okay? So the way to do that and create the negative is by making the 5 positive, the 1 negative, and now I can go ahead and do some solving, right? I can use the zero product property to break this thing apart. I can say 2x plus 5 equals 0. I can say 1x minus 1 equals 0. The one on the right is really gosh darn easy to solve. I just add 1 to both sides and I get x equals 1, and I'm done. There's one of my x-intercepts. That tells me I'm going to have an x-intercept at the point 1, 0. Okay? The other one, a little bit more work, but not much. I subtract 5 from both sides, and when I do so, I get 2x equals negative 5, and then I divide by 2 to get x equals negative 2.5. It's a coincidence here that the x-intercept and the y-intercept are the same. Don't necessarily falsely conclude that that's always going to happen, but this would just be negative 2.5 and 0, right? And we could, of course, check our solutions, remember, by doing some graphing. That would be a very, very good method here. Go to desmos.com. I would fire this function in its original form. I would verify that my x-intercepts are 1, 0 and negative 2.50. And you could go ahead and verify that. Could also check using the quadratic formula, right? There's another option. Okay, we already did that rewrite, and we came up with some equivalent equations that are easier to solve. Well, I've got a couple more things that I'm just going to talk about rewriting, and then we're gonna do some solving. Okay, look at all these problems. I suppose we do these in different colors. All right, look at all these problems here. I got, like, for example, problem A, and what I notice here is that every single term has a 32 that's being multiplied by it. So it's like this: 32 times 3x minus 32 times 5. And that's equal to 32 times 7. So what that means to me is I could go ahead and I could eliminate that factor of 32 by dividing. Okay, and what happens is these cancel, and now I can do some pretty straightforward and easy solving, right? So there's my rewrite in pink there. Those cancel, I get 3x minus 5, and that's equal to 7. Now look at how much easier that's going to be to work with. All right, I can go ahead and add 5 to both sides, and now I get 3x equals 12. Then I divide by 3, and I get x equals 4. So just by simply dividing everything by 32, I've taken that and I've turned that into a quick two-step equation, and doing so allowed for a much quicker and simpler solving process. All right, that's the point of the rewrite. Okay, let's move on to, I don't know, letter B here. I've got 9,000 x squared minus 6,000 x minus 15,000 equals 0. Now look at this. These are big numbers. Nobody wants to mess around with such big numbers. So what are we going to do? We're simply going to divide everything by 1,000. It's going to cancel out all these zeros. Right? Part of this is a little bit of practice to give you the experience to know what you're looking for. I obviously, in a 15-minute video, I can't talk about every single possible thing that you're going to encounter. Now, be careful. I'm only canceling the zeros there because that's what dividing by 1,000 does. So now I'll get 9x squared minus 6x minus 15 equals 0. And this is where factoring would need to come into play. I'm not going to spend time factoring this one because we did just factor a quadratic, but I would go ahead and probably need to maybe use some algebra tiles there if I wasn't sure how to break up that 9 and how to break up that 15. 15 and 9, those are not prime numbers, so they would have quite a few more opportunities for factoring. Okay, let's move on to letter C. All right, C is an interesting one, and we will get more into problems like letter C later in this unit. And people don't like problems like letter C because they have fractions, and we're like, yuck, fractions. And we're not going to divide to cancel anything here. Rather, we're going to multiply. Okay, here's what I mean. I recognize that in letter C, every single one of these things has a denominator of 3. So that means I can multiply each term by 3, and I can cancel that denominator. Now notice what I've done again. Just like in A, just like in B, I've done it to each term. Okay, so these will cancel, and these will cancel. And then look what happens. Look at how much easier this problem becomes because I recognized what each of these things had in common. Now I have 1 plus x equals 10. And it's like, holy cow, just subtract 1 from both sides and you get x equals 9. And now you're done with that problem. Okay, again, because I strategized, I recognized exactly what was happening ahead of time. Okay, one last problem in letter D, and before I do letter D, I'm going to encourage you to just spend a second because you've seen something like this before. Pause the video and see if you could rewrite this using one of the strategies that we've talked about in order to make this problem easier. I'll give you a second here. Pause the video. How'd you do? Did you get it? Did you figure out what you should do? Well, I tell you what I'd do. I'd go ahead and I'd multiply again. But what are you going to multiply by? I want that 0.5 on the 2.5 canceled, so I'm probably going to double everything again. Okay, and if I double this, and I've got to double this, I also have to double that 0, even though it doesn't really matter, okay? Because, of course, 2 times 0 is 0. So I get 4x squared plus 8x, and then minus 5. Now I've got a bunch of integer coefficients, and those things are going to work with factoring, okay? One more time, I'm not going to factor this problem just simply because we've seen stuff like this quite a bit, and so I'm going to save some time so I can move on to some other examples, okay? We're going to go ahead and look at 10-25 here, and in 10-25 we see a couple things that have me doing some solving, but we're going to be solving for variables that exist in the exponent, okay? Check out letter A. Letter A says 2 to the x plus 3 power equals 2 to the 2x power. Now look at this. For the first time, we're going to be solving algebraically here without graphing. We're going to be solving algebraically for variables that are in the exponents. And what I want you to recognize is that we've got a base here, and the base is the same. Because we have a base that's the same, we can cancel that base. Now, it requires a little bit more than we have knowledge of in nonlinear algebra. Okay, it requires this idea or this concept, this inverse function that we haven't talked about yet called a logarithm. So I'm going to ask you to take my word for it and trust me. If you keep on through geometry, through algebra 2, you're going to get exposed to logarithms, and you will have a good depth of study, and you'll understand why those bases cancel. But ideally, if I recognize that they're the same, we can cancel them out. Okay, so I get x plus 3 equals 2x, and now I'm just simply going to subtract the x from both sides, and I get x equals 3, and there's my solution for A. All right, I'm going to keep on keeping on. I'm going to move over here to B, and B is going to work the exact same way. What do you recognize about B? I've got 3 to the 2x plus 1 power equals 3 to the third power. Well, again, the bases are the same, so what I can do is I can cancel those bases. Again, we're believing in this idea that Anderson's telling us about, this thing that's going to be coming down the road called a logarithm, and we're going to rewrite it like that, and now I've got some simple algebra. Subtract 1 from both sides, divide by 2. I challenge you to do that on your own, and you'd get x equals 1. One more strategy I'm going to show you in solving for a variable in the exponent is what to do if you run into something like letter C. Letter C says 9 to the x equals 3 to the 40th power. Okay? Check out letter C here. Because now you might be looking at this and going, well, gosh, Anderson, what the heck? The bases aren't the same. 9 is not the same number as 3. And here's where the rewrite comes in. I recognize that 9 is the exact same thing as 3 squared. Right? 3 squared is 9. 3 times 3 is 9. So what that tells me is I can rewrite this as 3 squared to the x equals 3 to the 40th. And now, using properties of exponents, 3 squared to the x is 3 to the 2x power, and that's equal to 3 to the 40th. And folks, look at that. Now those bases are the same, so I'll cancel them out. I'll set those exponents equal to each other, and I get 2x is equal to 40. I divide both sides by 2, and I get x equals 20. And that's how we can use a rewriting strategy to solve that problem. One more we're going to look at, and it is letter D here. Letter D, sorry, I got to find it. There it is. 8 to the 70th power equals 2 to the x power. Holy cow, 8 to the 70th. Well, again, the bases are not the same. But I recognize that 8 is a power of 2. I know that 2 times 2 times 2 gives me 8. So that's 2 to the third power. So instead of writing 8 to the 70th, I'll write it as 2 to the third to the 70th. And that's going to be equal to 2 to the x. Okay, now what impact does that have? Well, 2 to the third to the 70th is 2 to the 3 times 70th, and that's 2 to the x. And 3 times 70 is 210. And now I've got those bases matching. So therefore, drop those bases, and x is 210. There we go, folks. We've got a little bit of preview for you guys to try to get us to identify and ask some of those questions. Try these things. Follow up with questions with your teacher. Ladies and gents, thanks for watching. Have a great day.